Let's talk about the allotropes of phosphorus and the compounds of phosphorus.
Yes,
Starting with white phosphorus. White phosphorus is typically written as P4. It is
yes,
a strained molecule because three-dimensionally it is aligned with sp3 carbon. All of them are sp3
yes.
carbon, but they are interconnected to each other like this. Okay,
Hmm.
because of which the angle which it is making is close to 60 degrees. Expected angle is 109 degrees 28.
109 degrees, 28 minutes.
Very good. But it is under a lot of strain. Because of the strain, it is highly reactive. It
Yes,
is insoluble in water but soluble in CS2 because overall there is no dipole moment. Dipole moment is zero. Hmm? Hence, it
yes,
is more non-polar nature, soluble in CS2. It
yes,
readily catches fire, and P4O10 is the form which it takes after catching up with fire, and it is a white dense fume. Since it
yes.
is insoluble in water, it is generally stored in water itself. It is
Okay,
poisonous as well as it does glow in dark. Okay. The
okay,
property of
yes,
glowing in dark is called as chemiluminescence or phosphorescence.
okay.
The next allotrope is red allotrope. When white allotrope is being put it in an inert atmosphere for several days with high temperature, 573,
Hmm.
it will turn into red phosphorus. Red phosphorus is
Okay,
actually a polymeric form. Okay.
okay.
If you notice the white phosphorus has this bond, imagine this bond has been broken and you put a dot here and dot here, and you just expand those dots by making bonds. So this is what will happen.
Yes,
So there will be expansion of these bonds like this.
yes.
That makes this phosphorus as sp3 hybridized group. Okay.
Mm-hmm. Yes,
And this phosphorus is less reactive than white. It does not catch fire. It reacts with O2 only on heating. It is
right.
insoluble in both water and CS2.
Okay.
Because it is a polymeric form, it becomes insoluble even
Yes.
in non-polar solvent. It is non-poisonous, it does not glow in dark.
Hmm.
Whereas out of three allotropes, I mean there are many, black one is the main one. The black one is the thermally stable allotrope. It
Okay.
is also a polymeric form and it has layered structures. Okay.
Yes.
If you could remember how the diamond will have different polymeric structure like
Hmm.
that. Here, phosphorus would also have, black phosphorus would also have the same kind. If you
Yes.
are taking red phosphorus around 803 kelvins in a sealed tube and keep it for a long time, it will become
Hmm.
an alpha black. Alpha black will appear with an HCP packing. HCP means hexagonal close packing.
Okay.
While white phosphorus, if you keep it around 473 kelvins, it will become beta black phosphorus, which is FCC.
Hmm.
And if you take white phosphorus heat to a very high temperature, the bonds will break. Initially, it will become a P2 gas. Got it?
Okay.
And P2 will have very similar nature to that of N2 with a bond order 3 diamagnetic, but it is unstable at low
Mm-hmm.
pressures. It is only stable at high pressures.
Okay.
Clear?
Yes, sir.
Let us understand what are the compounds of phosphorus, starting with phosphine. Important way to get the phosphine is taking the phosphates directly and hydrolyzing it. So if I take calcium
Mm-hmm.
phosphate, hydrolyze it, I'll get calcium hydroxide and pH3. Instead of water, if I take HCl, you'll still get CaCl2 plus pH3.
Yes, sir.
If you take a PCl5 and reduce that with lithium aluminum hydride, then the H minus will attack, Cl minus will be relieved.
Mm-hmm.
So that makes it pH3, LiCl and AlCl3.
Yes, sir.
And see, heating of phosphorus acids, if you notice, H3PO3, right? In fact,
Yes,
this
sir.
we discussed it as a general property of phosphorus that it would always go towards -3 and +5 oxidation state, any kind of phosphorus acid. So you can see,
Yeah.
if I take this phosphorus acid and heat it, 1 mole of phosphorus will convert into +5, the other mole will convert into -3.
-3.
And that -3 formation is of phosphine. The logic fits the same even if you have P4 in NaOH. So P4 in NaOH will form PH3 and NaH2PO2.
Yes, sir.
So pure phosphine is non-inflammable. But if there are any impurities like some amount of white phosphorus is left over, or phosphorus, tetrahydride is present, that becomes inflammable. In fact, P2H4 burns in air and forms a vortex rings. Got it? In the presence of
Forms of
phosphine,
what?
vortex rings. Okay. So if you remember big steam, uh, big ships here, container ships, when they go, they will carry a gun just to show where their location is in case of SOS.
Okay.
So there they use this P2H4 to burn in air, and that will start forming vortexes like this. Got it?
Oh, sort of like a flare.
Yes, sort of like a flame. Okay, but that indicates the location. So it is
Okay.
very well used in that guns.
Okay.
And next, pure phosphine can be obtained by treating the gaseous mixture with anhydrous HI and then with alkali. See, problem here is pure pH3 in aqueous solution, it is not going to act like acid or a base, it is neutral.
Right.
But if I take an anhydrous HI, this pH3 will act like a base. It will take H plus and convert into pH4 plus and I minus.
Right.
And then when you add KOH, again you will retain back the pH3. So this will become Ki and H2.
Okay.
Okay. Hmm.
Yes, sir.
Phosphine is a colorless gas with a rotten fish odor. It is stable in gas but ignites at a temperature greater than 150 degrees Celsius. And
Okay.
on photochemical decomposition, it produces red phosphorus. Okay. So
Yes, sir.
usually it starts polymerizing into formation of red phosphorus.
Right.
It does react with copper sulfate and mercuric salt to give cuprous phosphide or mercuric phosphide.
Right.
So that is where pH3 will help it. Okay.
Right.
Now that is about pH3. The next components of phosphorus includes PCl3 and PCl5. How
Right.
do we prepare PCl3? Just you react directly the white phosphorus with Cl2. Okay, sorry, red
Okay.
phosphorus you can use, white phosphorus you can use. White is much more violent reactive. Red can be controlled. So usually
Okay.
red phosphorus is more taken. Red phosphorus in chlorine will make it as PCl3, considering the chlorine given is in limited amount. Another reaction is if you react with thionyl chloride, SOCl2. This is a very
Right.
important reaction. You can see it asked multiple number of times. P4
Yes, sir.
SOCl2 will convert this phosphorus into PCl3, the sulfur into SO2, and few more moles of sulfur will convert into S2Cl2.
S2Cl2. Okay.
Okay, so S2Cl2 is a molecule, planar molecule, which will appear like this.
Yes, sir.
Next, PCl3 undergoes hydrolysis. So when you hydrolyze it, you will get this as H3PO3 and 3 moles of HCl. This is again a question that on hydrolysis, there are two different types of acids forming. One is oxo acid, one is hydra acid. Okay.
Yes, sir.
Oxo acid is in +3 oxidation state, and you know that anything which is lower than you know +5 oxidation state, it will undergo disproportionation. So same thing will happen.
Yes, sir.
H3PO3 will disproportionate to give pH3 and H3PO4.
Right.
This is on decomposition. Acha, you can directly hydrolyze along with heat and then get this directly as well. Okay.
Acha. Okay.
This we have done it in organic reactions, that wherever there is a PCl3 reaction with an alcoholic group, that is OH group, whether in the acid or
Right.
alcohol, they both will get
Hmm.
replaced via SN2 mechanism to give alkyl halide or acid chloride.
Yeah.
Next, if you take 2 moles of PCl3, react with O2, it will become POCl3. Okay. Basically,
Okay.
here O2 and SO3 both will oxidize that PCl3 into POCl3. If I take
Right.
SO3, it will take the O here and leave behind SO2. So it got oxidized and SO3 got reduced to SO2.
Right.
Okay. Next, check out PCl5. P4 plus Cl2, if you take excess amount of chlorine, so that will convert into PCl5. Okay. Now
Okay.
P4 plus SO2Cl2, same thing. This is sulfuryl chloride. It will convert into PCl5 plus SO2.
PCl5.
This is
Makes
also
sense.
kind of
Okay.
a source of chlorine.
But how do you balance?
Where beta? This one.
Oh, this one, yeah.
You just put 4 here. Sorry, here. 4 moles here. So ये कितना आ रहा है 20. So put this as 10 moles. That's it. Hmm?
But, अच्छा, sorry, SO2 is coming out of the hose unit. हाँ, ठीक है.
SO2 is completely coming out now. Hmm.
Right.
Next is PCl5 on hydrolysis. First, it will convert into POCl3 and HCl. And POCl3 on hydrolysis further converts into H3PO3 and 3 moles of HCl. So every time there is one more chlorine that will keep coming out, and eventually you will get phosphoric acid.
Right.
Yeah.
Right.
Right. Next, reacts with molecules containing OH group to give chloro compounds. Okay. So that is ROH plus PCl5 will become RCl, POCl3 and HCl. Okay. And acid reacts with PCl5, makes into acid chloride, POCl3 and HCl. Got it? Same as PCl3, what we have done with PCl3, the same thing would happen. Okay. And next you see sulfuric acid plus PCl5 will make it SO2Cl2, and this will become POCl3 and HCl. Same thing, OH and OH will be replaced. You will get two chlorines here. Now nitrous acid, if you have, same logic can be applied. OH can be removed, chlorine can be introduced here, POCl3 and HCl. Boric acid also, OH can be removed, BCl3 can be formed, 3 moles of POCl3 will be formed. So you can see the reaction type is very similar. Wherever there is an OH group, whether it is in an acidic form or a alcoholic form, it will remove that. Clear? All right. One second. Just a minute. Now, whenever PCl5 is reacted with organic or inorganic molecules with nucleophilic oxygen, it gives POCl3. Okay. SO2, SO3, P4O10. Now, if you notice these compounds, correct? As soon as you react with them, oxygen gets inserted. Got it? So here, one oxygen will go, two chlorines will come out. So that's how it will become POCl3 and SOCl2. The logic here is the bond energy of P double bond O is stronger than bond energy of S double bond O. Okay. and that's why they
Hmm.
will try to get more associated with phosphorus than sulfur.
Sulfur. Hmm.
Same goes with SO3 also. So one oxygen, two chlorines here, one oxygen will go there. So we get POCl3, SO2, Cl2. Got it?
Wait, with SO3 it's SO2 Cl2, and with
हाँ
SO2 it's
बेटा, there will be one
SOCl2.
oxygen left, right?
हाँ ठीक है, okay, fine.
Correct. And the same goes with PCl5 also. If I take 6 moles of PCl5 with P4O10, you will get 10 moles of POCl3.
Hmm.
Now, will the same reaction happen with carbon dioxide and try to get COCl2? No. Reason being, now the bond energy of C double bond O is much stronger. So C double bond O is stronger than O double bond O. This one, O double bond O, which is stronger than P double bond O, which is stronger than uh, S double bond O. Okay, this is the order. So that's why.
COPOS, ठीक है.
Hmm. So that's why you cannot break C double bond O, try to make P double bond O, or you cannot break O2 and try to make P double bond O. Okay,
You can break P
that's
double bond O and try to make C double bond
yes. Okay, the other way is possible. So therefore, if at all I have carbon dioxide and O2, we cannot expect that phosphorus will try to make a P double bond O out of it. Okay, so these two
O.
will not make such type of POCl3 reactions. And PCl5 generally on heating will easily convert into PCl3 and Cl2. Reason being, these bond lengths are longer and easy to break. You know that
Yes, sir.
axial length is longer compared to equatorial length, and bond energy is weaker and higher for equatorial bonds. Okay,
Yes, sir.
got it. Acha, by chance, if this is given, beta, with fluorine it is given and chlorine is given, correct? Now
Yes, sir.
remember, even though the chlorine is on equatorial position, okay, its length will still always be longer than whatever with the length which phosphorus with fluorine it makes. Okay, even though it is
So
axial position. Okay,
chlorine will be longer.
chlorine will be longer because fluorine is a very small molecule, small
ठीक है,
atom,
हाँ.
so it will not make large difference whether it is in an axial position or equatorial position. Okay, so this will be the
Yes.
bond length form. And now when it comes to PCl5, as you decrease its temperature, slowly it will start making an ionic composition having PCl4 plus and PCl6 minus. And with PCl4 plus, it makes sp3 hybridization. PCl6 minus, it will make sp3d2 hybridization. Okay.
Hmm.
And if you have solid PCl5, it will convert into PCl4, PBr4 plus and Br minus.
Why
Okay.
this?
Reason being PBr6 will be extremely bulkier to handle.
अच्छा,
That
because
cannot form.
bromine is very big at.
Hmm.
So मुझे 5 मिनट सर आरती के लिए जाना है.
The PCl5 oxidizes fine, finely divided metal into chlorides. That is, if PCl5, usually what happens on heating, it will become Cl2, right? That Cl2 is the one which is an oxidizing agent which reacts with metal and converts into metal chlorides, right? So you
Right.
can see here chlorine is getting reduced, silver is getting oxidized. The same
Oxidized.
logic goes with tin as well. So Cl2 will react with tin, converts into SnCl4. Okay,
Yeah,
so
so
this is what exactly happens. Now, see what are the oxides of phosphorus. See, phosphorus exists
okay.
in two main forms of oxides. One is P4O6, the other one is P4O10. So, if I take white phosphorus, react with a limited amount of oxygen, chances are it will become P4O6. Okay,
P4O6.
O6. Basically, it is
How is that
P2O3 only.
phosphorus trioxide?
Basically, it is P2O3 only. It will exist in a dimerized form as P4O6. Okay,
I see.
this way. So, we'll have four phosphorus linked with oxides. Okay, so two linkage oxides here and
Right.
another two here and another two here like this. Okay,
Oh, I see.
because it is all sp3 hybridized, the actual structure looks like this: a chair here like this, a chair form here, and another form like this, another form like this. Okay,
Okay. Yes, sir.
P4O6 on hydrolysis will give you H3PO3 phosphorus acid. It is an anhydride of phosphorus acid. And if you're hydrolyzing it with some temperature, it will convert into phosphoric acid and pH 3. Okay.
Yes, sir.
And if you take phosphorus pentaoxide, P4O10,
Hmm.
so P4, when you react with excess of oxygen, it will become
Right.
P4O10. And P4O10 will have a very similar structure as that of P4O6, just that every phosphorus will have an extra oxygen, making a double bond O. Okay. That is one thing which is missing in P4O6, and that will be added to convert into P4O10. Okay. Well, you have
Right.
intermediate acids also, like P4O9, P4O8, P4O7. Basically, every time you have something like P4O7, you add one double bond O, rest
One
of them
double
you do
bond
not
O.
keep it. That's it.
समझ गया.
And all these double bond O, they are all formation of p pi d pi bonds only. Hmm?
Yes, sir.
So whether it is P4O6 or P4O10, you have 6 POP bonds. Here there are no P double bond O, but here we have 4 P double bond O bonds. Okay. Now, see, P4O10 in a way acts like a good dehydrating agent, beta. Okay.
Okay.
So you can see CH3COH, acetic
Hmm.
acid. When you react with P4O10, it will become an anhydride, releases water out of it. And when
Right.
water is released, this part of the acid will convert into metaphosphorus acid. Okay.
Hmm.
See, think this way, H3PO4, it is at the highest oxidation state of phosphorus, correct?
Right.
An acid which is at the highest oxidation state of the central atom, if you try to remove water out of it, then the acid which is formed, that is always used with the prefix meta. So that's why it is called
Hmm.
metaphosphoric acid. Okay.
Right.
And of course, we do not have enough water to hydrate the entire H3P, I mean, everything of P4O10, right? So that's why
Yeah.
it will only be hydrated to a small extent, which will become a metaphosphoric acid.
Metaphosphoric acid.
And same goes with HNO3 also. HNO3, when you heat it, it will become HPO3 and N2O5.
Yes,
H2SO4
sir.
also, it will become SO3 and HPO3. And here anhydride also, what do you say, amide also converts into
Amide.
cyanide and HPO3.
Cyanide.
HClO4, Cl2O7, and HPO3. These are all the dehydrated form or the anhydrate forms of it. Okay,
Um. Uh,
clear,
yeah.
beta?
Okay.
Hmm.
Um.
Yeah,
HCl4 is perchloric acid.
perchloric acid. This is its particular anhydride. Okay. Hmm.
Okay.
Now, less common oxides, I told you about this. You may have 7, 8, and 9 forms also. In such case, when you are hydrolyzing, you will get 1 mole of H3PO4 and 3 moles here, 2 moles and 2 moles here, 3 moles and 1
Hmm.
mole here. And when you have P4O10, all will be only H3PO4. Got
Right.
it? Hmm. And what are the various oxo acids of phosphorus? Phosphorus, it depends upon the oxidation state, what it carries. If it has +3 oxidation state, okay, or +3 or
Hmm.
less than that, it will be usually referred as us acids, OUS. Okay, phosphorus acids. Clear?
Yeah.
Now, this phosphorus acids, if it is +1 oxidation state, it is called as hypophosphorus acid. If it is +3, it is simply called as phosphorus acid. And if I take 2 moles and then remove water out of it, then it will become pyrophosphorus acid. Okay.
Okay.
Remember, this is phosphorus acid. It has two segments to it. One is with
Pyrophosphorus.
+1 oxidation state, which is H3PO2.
Hypophosphorus.
That is by removing oxygen. Removing
Hmm.
water out of it, you will get pyrophosphorus acid. Okay.
Removing water out of it should make it H.
No, 2 moles. Take 2 moles and then remove water.
Acha, huh.
Hmm. Similarly,
Pyrophosphorus.
if at all I have phosphoric acid, which is +5 oxidation state, and if you remove water out of it, you get metaphosphorus acid, phosphoric acid. If I take 2
Right.
moles and then remove water, that will become pyrophosphoric acid. Pyro will always come like that because it has to give an oxygen linkage between two molecules. You will
ठीक
have
है.
to make pyrophosphorus acid that way. And now notice this. From pyrophosphorus acid, phosphoric acid, sorry, if you remove one oxygen, that will become again hypo. But this time it is
Okay.
hypophosphoric acid.
Hypophosphoric acid.
Hmm.
Right,
Clear,
not
beta?
hypophosphorus. ठीक
So
है.
these are six important acids. 1, 2, 3, 4,
So
5, 6, 7. Total, these are the acids which you have.
H4P2O6 is same as H2PO3, no?
Which one?
H4P2O6.
H4P2O6, this one. But no, the connections are different here. Correct?
So it's not a
Here it
dimer
is
form of
PP connection. No,
H2PO3.
no, it is not dimer form of. Okay,
Okay.
clear?
Yes, sir.
Next, see this. When it comes to oxo acids, we have all of these ones, right? Now notice one by one. The hypophosphorus acid is also called as phosphenic acid,
Okay.
which is represented as H3PO2 with +1 oxidation state. This is the structure. How do we prepare is simple. Before you react with any basic medium, NaOH, barium hydroxide, calcium hydroxide, anything, it will disproportionate
Yeah.
into -3 and +1 oxidation state. And once you
Yeah.
get this H3PO2 minus, you
Us
hydrolyze it again, you will get H3PO2.
makes sense.
Next, for orthophosphorus acid, it is also known as phosphonic acid. It is
Right.
called phosphonic acid. So H3PO3, this is the structure. It has, see, it has two H groups which can be acidic. Earlier, you have only one hydrogen which is acidic, which means its basicity is 1 in the first case. Here, the basicity is 2. Okay.
Hmm.
And next, pyrophosphorus acid, H4P2O5. So in here, you will, like I said, there will be one O connection here, oxygen connection. So due
Hmm.
to that oxygen connection, we'll get this. So PCl3 plus H3PO3, correct? So that will convert
Right.
into this hypophosphorus acid. Next,
Right.
orthophosphoric acid, H3PO4, and that is H3PO4. You can see if you hydrolyze it, P4O10, if you hydrolyze it, you'll get H3PO4. PCl5, if you hydrolyze, you'll get the same thing. And in fact, you know
Hmm.
that H3PO3, whenever it disproportionate, it will become PH3 and H3PO4.
Right.
Next is pyrophosphoric acid. So you take 2 moles of phosphoric acid, remove one water. So you will get this one. And here you see how many oxygen hydrogens we have. It are 1, 2, 3, 4. All 4 hydrogens are acidic. So its basicity is 4.
Hmm.
And that usually happens when you heat it around 250 degrees. So water will be escaped and you will get pyrophosphorus acid. And this is hypophosphoric acid. You take red
Right.
phosphorus, react in basic medium. When you react in basic
Hmm.
medium, first basic medium will break these bonds here. Okay. But one pp bond
Hmm.
will be left.
Right.
And because one pp bond is left here, you hydrolyze that in air. So the hydrogens which are present on this corner, they will get oxidized further. So again, you will have tetra acidic group here. That means there are 4 H groups, but in between there is no oxygen. So it is
Oxygen.
directly PP linkage. Okay. And in
समझ
fact,
गया.
this is the only product where you will have +4 oxidation state for phosphorus. Otherwise, you'll rarely, I mean, you will not usually find +4 oxidation state of phosphorus.
Okay.
Clear, beta?
Just for
Right.
ठीक है.
+4 is only absorbed by hypophosphoric acid. Okay.
Right.
Right. See. Next one, metaphosphoric acid. This is the 7th one which we discussed. HPO3. See, HPO3 is usually observed in a cyclic form like this. HPO3 some n times. If it is 3,
Okay.
that means it is a tricyclic group here. So you can see
ठीक है.
cyclic trimetaphosphoric acid, wherein
Hmm.
we have POP bonds making it as a 6-membered ring, and then you will have P double bond OH, P double bond OH, and P double bond OH like this. This is the connection we have. Okay.
Right.
And lastly, you can see cyclic tetra metaphosphoric acid. So we can have POP, POP, POP and POP bonds here, and P double bond O, OH, P double bond O, OH, P double bond O, OH, and so
PW.
this will be the cyclic structure here. Okay. So when it comes
Yes, sir.
to metaphosphoric acid, you notice that it will be either a tricyclic or a tetracyclic.
Yes, sir.
Acidic nature wise, H3PO2 is more acidic than H3PO3 than H3PO4.
Right.
The acidic strength is normally analyzed based on the stability of the conjugate base, correct? So if you
Right.
notice the stability of this conjugate base here, okay, you notice that in the phosphorus acid here, hypophosphorus acid here, there are two hydrogens on it. But when you have OH group on
Yeah.
it, this OH will try to destabilize by giving its own resonance. This is giving plus M
Right.
effect. And you know that plus M effect is more than its minus I. Here also we have plus M effect greater than minus I. So more amount of plus M effect, less will be the stability. Correct? So that
Right.
means conjugate base is becoming less stable. If the conjugate base is less stable, mean the acid is weaker.
Weaker.
And this also makes the difference that because phosphorus is at lower oxidation state, it will be more readily getting oxidized towards P with
Oxidized.
plus 5. Okay. So
Right.
therefore, reducing nature, H3PO2 will be more than H3PO3 than H3PO4.
Right.
Got it? Hmm. And see, during the reducing behavior, H3PO2 and H3PO3, both of them are oxidized to H3PO4. Okay. And
Right.
that means if you have any of these H3PO3 or H3PO2 and you take some good oxidizing agent like HgCl2, so mercury will get reduced and any
And
of
that
this
will
part
get
will get
oxidized.
oxidized to H3PO4.
Right.
Same even Hg2Cl2, if you reduce, it will reduce further into mercury and it will get oxidized. Copper
Okay.
will get reduced, this will get oxidized. Silver will get reduced and this will get oxidized.
That will get oxidized. Yeah.
Done. And lastly, you can see phosphoric acid, if you react with 1 mole of NaOH, you'll get this salt, NaH2PO4. And if
Right.
you heat it further from here, you can remove H2O from here, you'll get sodium metaphosphate. If I take
Right.
2 moles, I'll get Na2HPO4. You heat it, you'll get sodium pyrophosphate. And if I take 3 moles, completely, it will convert into sodium phosphate.
Right.
And that's this is in a similar reaction. That's why when you take magnesium ammonium phosphate, magnesium ammonium phosphate, it will convert into Mg2P2O7. Okay, sorry, this one is ammonium NH3. Clear? And
Right.
Mg2P2O7 is white in color. This is a white PPT. Remember, if this was a confirmation for ammonium as well as phosphorus, PO4.
Right.
Okay?
Right.
Right. So these are all the main reactions. This is a summary of the reactions of group 15. Got it? 20 reactions
Nice.
from NCRT. Got it?
Okay.
These are straight NCRT reactions. This is to practice better. Got it?
Yes, sir.
Clear?
Right.